Greetings, ladies and gentlemen. My name is Angel Lim, team lead for Narco NASA Suits. On today's episode of the NASA Suits Collab podcast, Narco Suits gets the opportunity to interview our mentor, James Stoffel, also known by his shorthand, Stoff. He is currently employed as an EVA Human Performance and Analog Engineer at NASA JSC and recently graduated from his master's program. During this episode, we covered his work at JSC, delving into topics such as 3D printed space habitats and the feasibility of establishing space colonies.
And I'm your co-host, Hiba Sayeda. During this podcast, we also talked about what it takes to become an astronaut, curiosity of space exploration, and how being isolated right now relates to what astronauts feel up in space.
Overall, this podcast had a lot of interesting conversations, and we hope you enjoy the ride.
My name is James Stoffel. I'm EVA Human Performance Analog Engineer at NASA Johnson Space Center. And currently I'm working with a talented group of teammates that we're all working on developing different systems that are getting us back to the moon, onward to Mars, and beyond. So I'm pretty humble and excited. I get to involve myself with various aspects, hardware, tools, vehicles, crew members, and it's an exciting time heading back to the moon.
How did you find yourself as an engineer at NASA?
Well, that's kind of a loaded story. That can start off from being as a kid in a military family, and I always had an eye to the stars. I've been surrounded by aircraft, spacecraft. I just had a really unique opportunity at a young age to see all those things. But really, when it comes down to it, it's just curiosity and imagination. So I think even if I was not uh, part of that type of upbringing, all I had to do was look around me and look at the wonderful people around me, look at all the wonders of our world, and then just looking up at the sky. I mean, there's so many questions. Why do they behave that? Why is it that way? There's so much around us that is art, science, engineering. They all live together and coexist. So and influence each other. So I think just the surrounded by awesome people and an innate and unique curiosity of just the world.
That's really deep, man. I appreciate you for giving me such a heartfelt answer.
I mean, it's not just space for me, actually. I, I, I study and I'm doing research and things that involve inner space in our oceans and marine sanctuaries, and and also endeavors here on our world on the ground, and looking at habitats for humanity and different uh, scenarios and circumstances that I can help and contribute, but and also the things that I can do off the earth, for the earth, and beyond, and outer space as well. So all those endeavors and challenges and failures and successes help contribute back to society and help all of us here on this beautiful pale blue dot we call home.
So, in regards to the research that you're currently doing right now, specifically the stuff that you're doing at NASA and maybe some of the stuff that you've done on your research thesis, is there anything that you could talk about?
Yeah, sure. So lately, these days, I've been working on the new spacesuit for NASA. So there are different various aspects of it. And really, honestly, I'm going to say a gazillion. It's not a gazillion, but there's a lot of people working on the new spacesuit that's going to the moon, and eventually some version of that going back to Mars. There's different aspects such as different aspects of it, such as informatics, display systems, the tools, the ergonomics of gloves, uh, how to do those operations and operate inside a spaceship. Really, the spacesuit is a spaceship. You're enclosed in this system. So, I mean, there's a lot going into it, all the human factors, all the technology, and so forth. And then, you got to start looking at, well, how are we going to get there? What kind of vehicle is it? What types of vehicles? What transitions and those concept of operations, those subsystems, and how long is it going to take? And we got to protect ourselves from these extreme environments. So there's a lot going into that. So it's a lot of human factors, and there's a lot of technology and advancements we're working on, and doing it bigger, better, and faster, and more exciting. And so that's one aspect of what I'm doing at NASA. And then recently, I just graduated from the University of North Dakota, and I got a Master of Science in Space Studies with a focus, major focuses on human factors, but also kind of a side focus of space life sciences. So my thesis research was on critical contingency EVAs for 3D printed planetary habitats. And I basically wanted to look at all those tools, concept of operations, techniques, methods, habitability, maintainability, feasibility, acceptability, all those things of how do we live if we're going to go to the moon and Mars or anywhere else. Um, how do we make it efficient? So we want to be cost efficient about it. And it's really hard to bring everything with us, all those materials and resources and consumables. So when we go there, there's a wonderful notion, and it's actually a, a strong drivers to do in situ resource utilization. And basically, instead of taking everything with us, let's use the resources along the way or at those destinations. So 3D print technology has been blooming and exploding throughout our industry, and they've already been testing and evaluating doing 3D printed habitats, not only for humanity here on Earth, but also looking at using like regolith, the moon and Mars, to build those habitats. Well, it's one thing to go build it and then you want to go live in it, but since you're so far away, you don't have a Home Depot, Aces Hardware, Lowe's, or Menards, or whatever you got near you. It's not around the road or around the corner, right? So you got to figure out what exactly can I bring with me, and what can I do to use those resources or create at those destinations. So my thesis kind of focused on how do we do these things if there was a variations of failure. It might be a major failure like a critical contingency, where you have to go repair your 3D printed habitat. What does that look like? What kind of tools do I need to repair that? What kind of methods do we use to repair it? Do we need to repair it? Do I need to use robotics and EVA? It tackles many of those questions and looks at plausible solutions, and then potentially it definitely opened up more questions. You know, there's lessons learned that I got from that, and from the industry, and all the resources or wonderful people out there that I had the opportunity to ask about. And so it was a good research endeavor, and it opened up a lot of ideas and start tackling some of those EVA gaps and human research program roadmaps and the NASA taxonomy as well. So there's that. And then I also worked with another talented team. We put together a team called the Dinonauts, and basically we sent up some blue glowing microorganisms from the ocean called dinoflagellates, and we used them as a model organism and to study the enzyme kinetics of them, to see how they change in respect to being on Earth and being in microgravity. So we got a chance to fly those up on Blue Origin in Christmas time, around Christmas time. So that was pretty exciting as well. So that was my graduate study research endeavors, and I've been tying that all together with the work I've been doing at NASA, and I spent a decade in emergency medical services, and I also used to be a rocket propulsion engineer. So it's been fun and exciting to tie all those different experiences, skill sets, and new skill sets and new knowledge all together, and hopefully do a lot of good for our world.
Yeah, you have quite a long rap sheet. I was particularly interested in the 3D printed environment work that you were talking about earlier. So can you explain more about what NASA's trying to do with that, and then specifically the 3D printing part?
Well, I mean, right now there's many methods to 3D print, and there are different, space agencies such as NASA, ESA, and other academia and private organizations. They're all trying to work together and figure out how do we use this material there. Say if you look at lunar regolith, but it has no atmosphere, and you get these extreme temperature thermal variations, the composition and various things like that. So that starts putting interesting constraints and variables into the design of what kind of 3D printer and what kind of method can we use. Are we bringing glue with us to glue this all together? Are we selective laser sintering or melting it together? Are we making building blocks or walls or one monolithic structure? Is it hollow cavities like honeycomb and they're filled with loose regolith? Are we protecting for extreme thermal environments, the radiation, micrometeorite impacts, human impacts? There's a lot of science, the kinetic energy, and all kinds of things that go into it. So right now, all these organizations and agencies and so forth are working on figuring out what are the best methods to 3D print these habitats? And I mean, even at that, are they pressure vessels or not pressure vessels? So the way I looked at it is it was a protective structure. So my robot's going to go, they're going to 3D print this protective structure. And then we're going to bring our inflatable or rigid habitats or semi-rigid habitats, and we're going to stick them inside there, deploy them, and live within this. So it gives us this protective structure to keep us safe. And I kind of tackled it from that perspective, and looked at the different ways that we could potentially build and fix these, and how we can risk mitigate it in the design. Like I started trying to identify all these potential failures, and then so I came up with these different repair methods, and based on those results, it's like, well, you know what, we might not have to repair these methods if we're really clever and we realize how difficult this is, and we can go and design it into that habitat so that's not an issue, or risk mitigate it so much that it's not going to be a close, not be is a plausible problem. I mean, anything's possible. You never want to say never, but yeah, so that was pretty fun and exciting. And then when you go to Mars, those thermal variations are even different as well. And you have an atmosphere, so you got weather erosion and a lot of other factors that can come into it. So yeah, there's a lot to look into it depending where you're going.
So essentially what you've been doing is just planning out the contingency plans for all these environments, like the specific design of it and how it would, function on Mars or whatever environment have you.
Yeah, and it's all kind of dependent, and they're all potential plausible solutions that they all are all plausible, and they're all for the most part acceptable, but there are some hurdles and lessons learned, some refinement in the tools or refinement in the technique, or things I realized that if a crew member's hunched over a habitat and they got this spacesuit that's weighing down on them. So in space, it doesn't really matter. When you're at the space station and you're on a robotic arm and on this portable foot restraint, you got a crew member and you turn them sideways or upside down. It doesn't matter how much that suit weighs. I mean, you can put a moment in it and so forth, but you're not weighed down or feeling discomfort from the suit. But now if you go into a gravity environment, a partial gravity environment, and you're hunched over something for a while, this suit probably get heavy and start pushing on certain parts of the body that are not going to feel good. And one of the things you want to do is risk mitigate injury during an EVA. So that's where technique, the design of the systems, you may need an offloading system such that it holds a suit, but the suit's not weighing down on you, and you can still use your arms working on top of the habitat. So it opened up a lot of interesting questions and potential workarounds. So it, I hope, and I look forward to seeing more work come from it and start exploring these.
Are there any designs for these 3D habitats that you can share with us, or is that like all classified?
Oh no, I mean, so they're all notional. So recently, you can go and look at NASA's Centennial Challenge. They had a 3D printed habitat challenge, and it just finished. I think it was just last year, and it had multiple phases from different universities and organizations and stuff. And they went printed everything from small coupons to subscale, almost full scale habitats, and they would put them under hydrostatic tests and pressure loads, and they tried all kinds of different things to look at different binders and techniques and how they would withstand these different environments. So you can get an idea of what they're looking at, and then you can also go look at places like at KSC that's working on 3D printed technology on their websites, and then ESA has a large endeavor, and our partners, it's an international endeavor, doing human space exploration. So ESA has got a lot of work that they're working on and developing a center over there to continue studying and look at these different manufacturing methods. So, I mean, for the most part, it looks like it could be anything from melting, sintering, using energy and waves to bind things together, anything from harvesting compounds to make binders there, or bringing stuff with us. I mean, so it just kind of all depends on that mission architecture that you finally decide upon. It's kind of a weights and balances and trade study that you're going to have to do. There's nothing set in stone. There's no set design in stone. And we're a few years from it. First, we need to prove to ourselves and work on getting boots back on, right? And do it safely and efficiently. And then once we start doing that and continuing a sustained presence on these bodies, we're working along the way, meeting these milestones and down selecting and figuring out how we're going to stay there. I mean, what kinds of rovers, what are these habitats? Are we going to have interim habitats, or is there going to be a permanent habitat right away? Things are going to come in stages and phases. So there's a lot of things yet to be determined, but we're definitely on our way heading that direction.
But it's going to happen, right? Like, we're just really
It's
far
going to
off.
happen. It's a matter of time.
Yeah. I mean, the whole concept of 3D printed environments and then putting them on space, that's pretty much like the first steps in space colonization, right?
Yeah, definitely. I mean, ISS, they have a 3D printer up there, and they've been testing and 3D printing plastic objects, and I think they already sent up an upgraded 3D printer. They even looked at, we have residual material, or structure supports that you get in different types of 3D manufacturing, or maybe you had a bad print and you toss it in a can. But they sent up, I think they recently sent up a recycler, so they take those materials and create new filament from it. So that's pretty cool. But at some point in time, you're not necessarily going to have plastic, or you could create plastics at these different worlds and get the compounds that are needed. But you can also look at selective laser sintering and melting with alloys and metals. And that's going to become really important, especially when you go to these far off distances, when you need those tools that are not made of plastic or not made of regolith and so forth. So that it is a fast growing, exponentially growing industry of additive manufacturing, which is, I think, a more technical term for it. Everybody pretty much knows it as 3D printing, but we keep discovering new ways of how to print these things. I mean, it might be a vat of liquid, and as you're pulling your frame up, you're using their photopolymer liquid, and you're using light to solidify this object, or you're melting sand and you create this glass structure. I mean, there's so many ways you could do it. You could be wire feeding a metal spool of wire, like I think Relativity Space, a propulsion company, they're making propellant vessels for their rocket the propellant pressure vessels for their rocket, and they're 3D printing it in place, which is just phenomenal. And using a robot to do that. I mean, there's so many innovative endeavors going on out there. I'm just excited to see those and any other new types of methods they're going to do. So, I mean, so we can only do so much when we get there and use those resources, but I think we got a lot of clever people on this planet to figure that out.
Yeah, I didn't even think about that aspect of it. The fact that if we do somehow manage to create those systems that'll eventually create, space colonization, there'll be a bunch of industries that are going to be helping out with that. My question is, how long do you think, just like a rough estimate, it'll take for us to get to a stage where we can start creating these colonies on Mars or otherwise?
Oh, wow. How soon can we get there? As much, if you have enough funding and enough human power, we could get there pretty quick, because we got a lot of the technology, and a lot of it just needs to be tested out, and just need to have that funding to do it, and the right decisions made by the right groups and individuals and organizations. Now, with our current mission architecture and plans and funding and stuff, it's going to take a little time. It's going to take a few years. So, I mean, look, right now we're trying to put our boots on the moon in 2024. So we got a few years just for doing that. And then it could be by 2029, 2030, by the time we have more of a sustained presence on the moon, where we maybe having habitats and rovers and so forth. After we're having continued missions and we're learning more each time we go there, and we look at these craters and permanently shadow regions. You've probably heard of PSRs. We're going to the South Pole. We'll look at those resources, the water ice that we're finding out that we're gonna have there in the craters. Maybe it's lava tubes we're building our habitats and structures in, a combination with 3D printing. So there's a lot to be learned along the way. But to have a colony is having a certain number of people, right? I think the first step is, let's get there and study our environment. It's kind of like our early explorers in our world. We go there, we figure it out. We have small ships, small huts, and we kind of live there for a little bit, figure those things out. And once we understand that environment and the culture and everything around there, then we could start working with that environment and putting our noggins together to make it more sustained and turn into a colony. So we've got some years ahead of us, but it's really not that far away. So let me put a little perspective on this. The human space program is not that old. So, I mean, when did the Apollo program start for the most part? When did we start flying X-15s into the upper atmosphere?
Yeah, all the last century,
It's
huh?
been it's all within less than 100 years. Our space program is young. So yeah, for a while there, things kind of slowed. We had some lessons learned, things retired, but we still had a space program. And it takes society as a whole to get things going. And really, we only like fractions of a penny that we use for our current space program. But now we realize and see and understand how much of an impact technology has around us. I mean, a lot of us probably can't even imagine not having our computers, our phones, microwave oven, all these different things that weren't even being thought about 100 years ago, right? And now it's like every day, it's like, how do you live with that, without that? But a lot of that technology is derived from the space program, derived from doing these extreme, awesome adventures and endeavors that drive us to be innovative and challenge the new. It's kind of like, let me pick at this. One might say, well, why reinvent it when it works? Well, why don't reinvent the wheel? I was like, well, let me say something. And I say to reinvent the wheel. So should we have stayed with the wooden spoked metal rim wagon wheel? I mean, can you imagine all the cars having those right now? But we kept on thinking, we kept on improving. There's different environments, muddy environments, Arctic environments. There's all kinds of environments, pavement conditions. And I'm glad all those engineers and different people continue to refine and design and make these tires better, tubeless or have inner tubes and different tread and different plies. All those smart minds put together these awesome tires on all these vehicles. And the same thing can be applied to anything from the medical industry, the art industry, uh, everything you could do, from the chef to the welder to the philosopher, everyone. It's art influences science and science influences art. It's a symbiotic relationship. If you take a microscope and you go look at a plant or animal and you look at it really close, you're amazed by the complex math and geometry that's in nature. I mean, look at the hexagonal features, the spirals, all the little different things you see there. It's really mesmerizing, and it's biomimicry almost. We tried to mimic nature's efficient designs out there, which is kind of pretty neat. So I'll reel it back. I kind of went off on a few tangents there. It's amazing out there. We can do a lot and we can move really quick. And I think it's just a matter of getting everybody together and be excited about it.
Yeah, definitely. The power of human ingenuity is, I think, what you're alluding to, right?
Yeah. And then you also got to remember that sometimes laws of physics or science or things that, professionals or doctors or physicians of our time in history that solidified and created the basic building blocks for a lot of things that we understand. And even they realize and understand that they can be improved and changed, right? Like scientists used to say that your face would rip off at 60 miles per hour driving a car. If you went 60 miles, oh my God, your face is going to rip off. That's obviously not the case. At one point, there was a lot of rocket scientists said there's no way we're going to be landing tall candlestick rockets on floating barges or back on the ground. Reusable launch vehicles, no way. Look what we're doing now. I mean, so it takes those innovative people, the people with the resources to do that, and I'm open to that. You never want to tell yourself no. So there's a couple of things. There's quite a few things. There's a couple of things I say a lot. I say that always be a dreamer and a doer. So when I was a kid, I did a lot of dreaming. Yeah, I tried to do. What I mean by doing is that don't just dream, go do it. And then the other part is never give up. And I don't mean that like you can not necessarily give up. You can fail. All right. It's okay to fail. And actually that's something I wish I would have caught on to, the concept of failing when I was younger. And in reality is that sometimes when you have failed so much, you've almost covered every possible way you can fail, and you've eventually figured out every way to be successful. Now you're starting to become this subject matter expert. Now you're an expert. Because like Michael Jordan, he even talks about how many shots and games he's lost. But through time, he learned, he focused, he figured it out. He's a great in the world of basketball. I mean, I think Wade Gretzky said that you don't make any shots you don't take. Good point. So be a dreamer and a doer. Never give up. It's okay to fail 10 times. Some people might not feel like that. Some people might not like that philosophy. But don't beat yourself over it. It's not a failure unless you decide to stop trying, or that you learn something from it and you realize that's something you don't want to do or pursue. But really, as long as you're learning from it and you take something from it, even if the project doesn't go to completion that time, then you didn't fail. You've developed a new skill, a new experience that you can apply to the next thing, and you try to take the positive aspects out of it. So it's okay to fail. I mean, yeah, we're all don't want to fail, want to do it right the first time or the first 5 times, or maybe it takes a bunch of times, but you know what? Don't give up. It's all right. Even if you got to circle back around 10 years from now and you're like, oh, I'll never go back and do that. 10 years from now, you're like, you know what? Those experiences and all the other little ones I learned along the way, I got the solution now. I got an idea. Go tackle it again, or help somebody else tackle it, and then they figure it out. And they figure it out because you helped them.
So true.
Just don't give up.
Especially right now, like people are saying like they're giving up daily. Like not being productive. So it's like keep going and switching your schedule every day, seeing what works for you.
Yeah. And I will say something, since we're in difficult times right now, right? And there's something else that I learned really hard, and most college students or other scenarios do the same thing. We work really hard, drive ourselves into the ground, 80 hours, 100-hour days or something, or not days, weeks, and we drive ourselves in the ground trying to work so hard and make something work. I want you to keep in mind that you must take care of yourself to take care of others. So when I worked in the medical fields in EMT, and worked in the ER and everything else, and lab and phlebotomy, I used to work so hard and always worried about helping others, right? But if you forget to take care of yourself, if you forget to have enough hours of sleep, you forget to eat, you don't go exercise, and keep your mind, give yourself mental health, and take a time, take pictures, and take a walk, go do a hike, swim, whatever it is. Those are really important because it keep your mind fresh, happy. You're less discouraged. Stay healthy. You have to take care of yourself to take care of others. Because I hurt myself a few times worrying and taking care of other people and forgetting about myself. So it's not being selfish. It's making sure that you're still a functional person, human being, a resource to help others still. So it's a balance in life. So keep that in mind. Stay healthy so that you can help the world and humankind. Be a dreamer and a doer. Even if your dreams change, that's right. Some of the dreams that you had, or you have new dreams from it, that's okay too. That's not failure. It's a success. And then never give up. Just keep going.
All right, stop. Thank you so much. That was very inspirational. I'm hoping there's at least one person watching this that has a dream of actually, accelerating the time it'll take to put these houses and environments on Mars. And we can happily say that it was all thanks to you.
Oh, well, it doesn't take, there's no I in team, right? It takes Peggy Whitson and many others, it takes a village. So it's not one rocket scientist that makes a rocket go. It takes the software, it takes the admin, it takes the program manager, it takes the welder, it takes the mechanical engineer. It takes everybody to do something, efficient and safely, right? So I just look forward to working with the talented teams out there and making this a reality. So for me, it's like everything that we do, trying to go to these other worlds, it's not because I'm trying to escape, not at all. I mean, it's just another fun adventure. We do adventures here on Earth. I'm glad we traveled across these oceans and the skies and everything. You think about the people like, why would you fly across the ocean? That's crazy. We do it every day now. People buy tickets and stuff. I mean, yeah, so I'm all for the adventure. But the thing is that all these things that I tried and that I'm trying to do and doing in a space program, I want to take these and apply it back to our home here, our Earth, right? It's our only home. This is our spaceship. So we got to take care of it and the people here. So, there you go. I'm done talking. I've been babbling.
No, that's really cool. Like hearing like anything related to space, like makes me think that there's still more to learn or be more like curious about. So it's like, how you said, like there's always more questions. So like you find out one answer, then you have to find another answer for that. And it just goes on and on.
That's okay. It keeps us from being bored too. I mean, you can choose your battles, and that's another thing. Try not to overwhelm yourself trying to do too many things. I've done that too, where I gave a speech at my first my second university, University of Washington, where I got my undergraduate degrees, and I gave a presentation about being a multifaceted engineer, and one of the things I touched base on in there was about being a jack of trades. There's a phrase saying jack of trades, master of none, but there are ways to be a jack of trades, a master of one, a master of some, or none at all. So it kind of depends on the person and what they want to do. You can be great and happy with being an expert at one thing, or you might want to tackle a few things, be an expert of one thing, but really knowledgeable and well versed in these other areas. Or maybe it's a couple or a few things. It just kind of really depends on your time in life and what's going on. But I want you to also to keep in mind to make sure not to overload yourself and take on too many tasks. And it's okay to be pinched and reminded that there is a team around you, to be careful not to micromanage and let some people explore their mind, explore their efforts, let them try their new crazy idea that you may not necessarily agree, but you know what, maybe there's something for you to learn, because it always goes, I'm learning from y'all. I'm learning every day. I'm learning all kinds of stuff. It's great. I'm like, wow, I've been doing it that way all this time. Okay, there are other ways to do it. Cool, I like this. So you got to keep open-minded, and make sure you don't overload yourself so that you're successful. So it gets frustrating sometimes if you try to do too many things and you don't get any of them complete. Time management is an important skill, and communication is an art. So you can make the best thing since sliced bread and never sell one of them. If you don't know how to communicate it, right, it's just not going to go anywhere. And there's lots of great inventions and great ideas that are probably sitting on shelves, collecting dust or have been buried. So make sure to learn the art of communication as well.
So I've also watched like some live shows on YouTube. It'll talk about how it's not that safe yet, so there's still more things to go with the suit. But it's a lot of just watching things like from like a Netflix show. Have you heard of the Mars show yet?
Yeah. Yes. Mars. Yes.
So that was pretty cool. Like I saw them like struggling like in each episode trying to stay alive.
Yeah. So as humans, we've learned from a lot of our extreme environment analogs and adventures and research endeavors here on Earth, like the stations in Antarctic. So it's an isolated environment. It's harsh outside. So they spend a lot of time inside doing a lot of things. But yeah, I mean, they venture off into the field to study different things in the environment, ice cores, looking for meteorites, all types of unique, almost alien-like to us environmental conditions and stuff like that. So we have a lot to learn from ourselves here, and we have learned a lot on how to survive in isolated environments. And it's you're taking risks. You have to also be psychologically prepared as best as you can, and to understand what you may or may not run into and the risks that are associated with it, and be good with that. And then also it's important to take calculated risks, right? So you may want to go summit Denali or something like that, but you should probably do some training first along the way. Maybe do some rock climbing classes, do some backpacking, learn how to do some survival training and things like that, and understand what kind of trouble you can get into and how you're going to save yourself and others. And so there's lots of resources and experiences that we have that teaches us how to handle it. Now, obviously, there's elements of it that we just haven't been there, and they're not here on Earth for us to really understand. So, like, for instance, when I was an EVA instructor to teach the astronauts how to do a spacewalk, it's kind of hard to have a micro or a zero gravity environment to teach the astronauts how to use a spacesuit. We can't just turn it off. But we have different training facilities and simulations. NASA's Neutral Buoyancy Laboratory, it's a large pool, and basically we have the space station in there, and then we put the crew in the spacesuits, and then we weigh them out such that they're neutrally buoyant in the water, so that they feel like they're floating in space. But in reality, your bodies are still you're still in a gravity environment. So their bodies sinking to one side of the suit. You turn them upside down, they're going to start going the other direction. So there's only so much you can do. And then we got VR. So we have our VR lab, and they get in there, put the goggles on, and they have different devices they can hold on to and feel like they're in space. And then it works great. It's wonderful. And then we have the Argos active response offloading system, and that's in over at Johnson Space Center as well. And we put them basically in a harness, and we can simulate what a lunar or Martian gravity or zero gravity is like. So there's not one perfect tool or scenario to really train for these environments. But it's a combination of these different training environments in different classes and studying and so forth. And when you combine enough of those together, you put yourself in a pretty good position to do that mission, right? And then even when you get there, you'll be like, whoa, so this is a little bit different. And that was close, but not quite there. You know what I mean? There's things that we haven't figured out yet, because we didn't stay on the moon. We went, and we only went a few times and we left, right? And we've yet to put a human on Mars or any other world that I know of. But so there are things to learn. So and there's those extreme environments. I mean, one doesn't have an atmosphere, the other one does, but not quite ours. There's there's a lot to learn. So I there's only so much we can do. We take the experiences that we know that might emulate it or might be like it, or that maybe it's not exactly like it, but the skill set that you get from it might be or is very similar to that skill set. So, I mean, we even train on these NEMO missions, the NASA Extreme Environment Mission operations, where the crew and scientists and researchers, they go live in the ocean in this pressurized habitat down at the bottom of the ocean over the Florida Keys. And they simulate a 10-day long mission, and being in this extreme world where they do these EVAs wearing hard hats and walking on the bottom of the ocean, and they simulate these environments. And it's not Mars, it's not the moon, but it gives them the mission control perspective. They have to be safe and know how to use their breathing apparatuses and equipment. There's a lot of, and they're living in a confined environment. They have to learn all those good, roommate skills and things like that. So we have a lot of things down here that we can use to learn and train from.
How many years do you think it will take, to train? Like if someone starts from college to.
Oh, that's an interesting question, because the astronauts from the beginning of the space program to the astronauts that are now, there are different types of astronauts now. It used to be all fighter pilots, right? And then now it's a mixture of scientists and researchers and doctors and biologists and artists and pilots and all kinds of things, right? And they realize that as we progress into the vast cosmos and outer space, that it requires a lot of different skill sets and knowing how to be a human, right? So you can have a lot of the skills, but if you don't know how to work with a person or deal with stress by yourself or as a team, or deal with these environments, then you might need some additional training or some other things to learn how to. So you got to be able to handle it emotionally too, right? So how long does it take? Well, it takes so once you're selected as an astronaut, it takes 2 years to go through the training program. And then once you pass that, when you get selected, you get some assignment. And when you get selected for an increment going to ISS, it might be about 2 years. And then so going to Moon and Mars, they'll probably initially pick astronauts that have some experience already going to space. I might be wrong, and maybe not. But how much training to go to the Moon and Mars? At minimal has got to be probably 4 years. I mean, we have a lot of talented people, and even our new astronaut candidates are going through simulated tests and helping us develop these new processes and hardwares and systems that are going back to the Moon and Mars. So they're essentially already doing some of that training. So you never know. We could send anybody. I mean, I could go. It can go either way. I just want to put the best. I want to put everybody. I want to put everybody in space and on Moon and Mars. They got the skill set and they can do it, then send them, right? Yeah, it's gonna take a few years
Do you
to
have any
train for it.
advice, like, on how to be unique though? Like, because I've heard that you have to at least have a lot of skills with different sports, also maintaining your body shape and all that. Yeah.
Yeah, I mean, some of it might be kind of given, right? You got to take care of yourself in order to take care of yourself and others, right? And be able to work in extreme environments. I mean, if you probably can't run a mile without keeling over, might be a little rough being in a spacesuit doing an EVA on another world, right?
Yeah.
But it, so you may see a lot of people like, oh, you should do this and this and this, and that's what they want in an astronaut. But really, that changes every time. We kind of start figuring out things that are helpful, and you don't necessarily have to have that skill set. You don't have to have be a scuba diver. You don't have to have a pilot's license. I mean, they're going to teach you these things, but I mean, they're helpful, sure. There's a lot of things that are helpful, and
Hmm.
there's not one degree. All our astronauts have varying degrees, but really what comes down to, they're going to see your pieces of paper. It's like, okay, they went to school, they're smart, um, they varied, they got different hobbies and experiences. Um, they played in team sports. They know about teamwork. Hey, they they went to Antarctica for a research mission. And okay, they can handle some extreme environments. I mean, that's not a requirement, but yeah, and things like that. Oh, you're a pilot. You can handle uh, uh, multi-million, billion-dollar aircraft and handle these situations and be well trained and understand how to use those systems. I mean, all these little different things. There are extremes. There it's constantly redefined each time. I mean, it depends on your mission. So like you could be a pilot, a mission specialist. They used to have, payload specialists, and that might be coming back too. Who knows? And
Hmm.
as we have more sustained presence, like different space stations and these different companies that are going up, maybe like Axiom or Bigelow Aerospace and things like that. And then we're going to have private and commercial entities, and you never know. It's not just a government astronauts or entities, and now we got private astronauts and tourists and so forth. So uh, what it takes to become an astronaut, that's we're all figuring that out, and that's constantly changing. So it's gonna be a new environment. You
That's
the,
crazy.
the
Yeah.
best experience is do the things that you enjoy. Like I I would love to be an astronaut one day. But I didn't go do scuba diving because I thought that would make me an astronaut. Because I love the ocean. I love the animals in there. It was a really cool adventure. I just feel at ease down there, and there's just so much to gain from it. And uh, I love flying. I grew up around airplanes, and I'm working on my pilot's license because I want to take my son up and watch him giggle and laugh and fly to different areas and get a different perspective on our whole world, looking down like wow, and then looking up as well. So. I do things in my life that I enjoy and have a positive impact around me. Not to, you know, try to become an astronaut. But if those things happen to, have help that out, cool, that works.
That's a good way to
So,
look at it.
yeah, yeah. And so if you talk to astronauts and you ever ask them one day, it's like, oh, what does it take to be an astronaut? It's like they're going to tell you do things that you're passionate about and that you enjoy. That the odds are a little hard right now. Today, there's not a lot of astronauts. Only been 575, I think, astronauts in the history so far. So that's not many.
Mhm.
But in time, there's going to be more and more of a frequency, and things are going to change, right? You're enjoying life because you don't want to disappoint yourself. Don't go do things just because you think it's going to get you something. Go ahead and do it because you enjoy it and you want to try something new or whatever it is. Do it to enjoy it. Do it for you. And
Yeah, at
then
first it
yeah.
feels like a dream, like a random, like a kid dream. But like now seeing more girls in it and just like being around in like around people like space related has made me like think more like out of the box. Like I can do it if I just like try.
Yeah, that's all you can do. Just try, and it's all good. And then you also have to kind of accept at some point. Well, no, I don't want to say that because I always talk about never giving up and being a dreamer and doer. Um, and they tell you that make sure you don't just set yourself up to be disappointed. Like don't go do all these things, and you realize that if you happen to not become an astronaut, and then feel regret that you did all these things or you wasted time, it's not wasted, or you don't feel regret because you enjoyed those things nevertheless. Like, oh, that was fun, that was great, I had a great adventures in my life. Just, again, that's why they say make sure to do things that you enjoy, that you're passionate about, and no matter what you do, right? Sometimes we end up doing a dream that's bigger than that. I'm sure there are dreams bigger than that, right?
Yeah.
You might become the next best flight director, or the president of the United States, or a country, or congressman or congresswoman, or whoever, a leader of our children. You never know what your adventures are going to lead you to.
Mm-hmm.
So you never know.
So true. Yeah, you have to just have
Yeah.
fun in life, and then
You have to
if
have
that
fun.
goal happens to happen, it happens. If not, just keep going.
That's right. No regrets.
All right, thank you so much, Stoff.
You're
I
welcome.
personally took a lot out of that segment as somebody who also wants to be an astronaut. So all I can really say is thank you.
Yeah,
You're
thank you
welcome.
for your time.
Hey, thank you for sharing your experiences and teaching me new things and putting a smile on my face, because I love helping out people, giving them my experience and lessons learned. If it helps you do great things, awesome. I look forward to seeing you on TV, in the news, or out there, or walking by you one day. It's like, hey, haven't seen you. Like, what'd you do? Oh, I cured cancer. It was really hard. We worked with the team. It was like, that's phenomenal. And I look forward to things like that. Or even like, yeah, I painted a really great painting the other day. I was sitting on the beach over in the Pacific Northwest, and it was really inspiring. That's awesome. I want to be excited about the things that you're doing. So, I look forward to
Yeah, the little accomplishments are everything.
it.
Okay, James Stoffel, ladies and gentlemen. We'll be seeing you next week during our NASA Suits meeting. Stay safe until then.
Will do.
Take
You all
care.
too. Take care. See you later, everybody.
You too.
Bye.
Thanks. Bye.
All right. Bye.